Well, here we have the last chassis in the series of 4 for the same person. This is a K7400. It says recapped, new HOT, new flyback, I did the work, does not power, I hear a ticking noise. So that's very indicative of a shorted HOT. But let's verify and find out. See what we can find here. Ah, this is one of the newer ones. One of the last production runs where they changed out the heat sinks to the better style. And we're going to have to cut this off of here so we can investigate our solder joints on our transistors. And wow, that looks pretty good. Crazy. It's a very low life, good condition, almost basically brand new 7400. And I always put these back on, so don't worry about that. But all right, let's inspect our pots. Okay, they're all in the center, so I guess I can leave them that way, but I'm going to go ahead and put them about the 25% mark. I used to put them in the middle, but I find, like I say before, they get overdriven depending on what tube you put it on. So we'll leave the drive pots in the center, but for the bias pots I'll put them about 25 or 30%, just pretty much a quarter turn up. But this looks pretty good. The caps appear to all be in correctly. So yeah, I think our neck board's in good shape. Let's go ahead and disconnect it here. Hopefully this is a quick and easy one. Been having a lot of tough ones here as of late. The G2 wire is soldered in instead of they took the post out and soldered it in, and that's fine. It just makes it a bit more difficult to remove, but not that hard. We just need to desolder the G2 wire and take it out. This has the pincushion board, which is pretty much a worthless mod, but it's here. We're going to... Oh, it's hardwired in. Oh, wow. I have never seen a pincushion board hardwired in or soldered in. It's hard soldered in here. That's a first for me. I wonder if the person that owns this did that. I can't get this remote board off of here. There we go. Yeah, they changed out the caps on the pincushion board, and then I don't know if they soldered it in, but it's hardwired. And you can see here I've got a bunch of these just laying around. I always take them off because they don't do anything. They just make the image round versus square. I got a bunch of them just sitting here. But yeah, there it is. I mean, I'm not going to worry about it. Let's set the pots to the center position. So we have a baseline for the pincushion. That's okay. Those are both centered, so I guess I can't take it off. We'll leave it there. Now that our iron is on, we can take our G2 wire out of here. Okay, we shouldn't have to do any work to the neck board. That's good. Remote board. We got a contrast pot kind of smashed down, but no problem. That seems okay. Yeah, not bad. Okay, main board. Let's see what you're hiding here. Why is it ticking? Well, Q708 is in pretty bad shape here. Yeah, I don't know, that's pretty bad shape. It was smashed over pretty good, and it's kind of wobbly. and the center leg looks like it's about to break. Maybe not. Yeah, we'll test it. That's not going to cause the ticking noise. It's just, if that was bad, it's just going to be dead, because this feeds the LA7851 chip, and if this chip is no good, it won't boot either. So yeah, I think it's not, none of the legs are broken. It just feels odd, like there's bad solder pads, but no, they seem okay. We'll test it, no big deal. Sub-contrast pot, it's already set to center, so that's good. Alright, let's see if we can figure out why it's ticking. So normally when these are ticking, the HOT is shorted. So let's just test our HOT. And place your bets. I don't like this. There's a jumper across here. I don't like that. So we'll get the fiberglass pen out and fix that trace there. Not a problem. But for the purposes of this, let's go to Diode Checker, and HOT is shorted. So he said he already changed out the HOT. So there's something else that is causing it to be shorted. So we can test C121 as the most common culprit on the K7400 to cause the HOT to go out. So that's going to be these two pads right here. This one and this one. Shorted. But is it reading shorted because the HOT is shorted, or because C121 is shorted? The HOT could be good, and it could be the bad C121. So let's just take C121 out of the circuit here and see if that in fact is shorted. There we have it. And what's the verdict here? It is not shorted. So our culprit is not C121. Let's test this again. Still shorted. Okay, so we'll leave C121 out for now. Let's remove the HOT. And see if our pads are still shorted. Because we had one very recently where it read shorted in circuit, but was fine out of circuit. And it ended up being a shorted capacitor that was causing this. But the owner of this already did a cap kit, so I doubt that it's a bad capacitor. We're going to have to do some troubleshooting here and figure out why the HOT is being taken out. Should not be too difficult, but those are some famous last words. Okay. Oh, well, I think I know what the problem is, because this is wrenched on here unbelievably tight, and I bet you they poked through the insulation, or the insulator, onto the frame. Ugh. But I can't say that for sure at the moment. I can't say that for sure. Okay, out it comes. Let's inspect here. Doesn't look like anything is shorted to that. But you never know. Let's see what it tests out of circuit here. Absolutely shorted. Let's test our pads here. Well, I don't know if that is supposed to read. That seems rather odd. Let's test our poly caps here. There's 3 poly caps here that can be bad. These 2 here, or this one. Any of those being bad can cause the HOT to go, but usually if any of those are shorted, you'll read shorted across the HOT pads, but I'm going to test them anyway. I believe it's, let's see, this one, not shorted, this one, and this one. You know what? That's odd readings here. Hang on a second. Where's this other one? Those are all gone. Okay. Let's grab this one here, because I don't think that that's correct. Of course, this one has an HOT in it, but I just want to see what this reads, because across, where did those go here? Yeah, across here. See, that's shorted. And then this one is diode, and that one's diode. Because let's put an HOT in and see what we get. Because that just, yeah, this just seemed odd to me. Why that was like that. That is this one here. Yeah, see, that reads a diode. That does not. This one. Yeah, let's put a HOT in there. That's just very odd. What is that? 3688? Okay. I don't think I have any of the 3688s. Yeah, these are the 1398s for the 7000. Yeah. I think all I have are the FJL ones, the beefier, more robust ones. I got some Q703s here. Maybe I'll replace that, but let's see. NIC transistors. Yeah, I do have what looks like an original 3688 in here. Uh, 3686. Yeah. So let's put this one in here just to see what we get. And it's good. You're only going to read to one leg out of circuit. The other leg is going to be open until you put it in circuit, then it'll read to 0.5 to each leg. So I just want to see if, well, I'm running out here. I only got 3 left. Probably going to end up having to use one for this. Let's just see and make sure that we didn't have it shorted to the frame here through the insulator. Just snug is all you need, so let's solder it in. Alright, so now what do we get across these polycaps? This one here. Still got the diode. Nothing on those. Switch this around. Diode. Diode. So this one that's working, if we test it, we get what I could keep putting it backwards here. If we test it, diode, diode, diode. Well, I guess that's what it's supposed to read. Okay. Well, let's fix this really quick here. I'm not sure why that's even like that, because I don't see a break in the trace there. Man, that's a stubborn one. There we go. Alright, well, let's take a look at this and see if we can spot anything that jumps out at us that would explain why the HOT would go out. But in the meantime, let me prep these so I can put C121 back in. And let's test our HOT, which I think we already did, didn't we? Yep, so we don't have anything shorted on the line. What about C119? C119 is here, and it's not shorted. Is it supposed to read that? Yep. Yeah. C121 is back in. Why are you like that? There you go. There you go. Well, is there anything that can possibly cause that from just looking at this? We got some suspect solder joints here. Looking around here. Well, let's test Q703. Should be 1.0 to the outer leg. Close enough, 0.9, and then this is our voltage drop. Yep, so Q703 is good, despite my misgivings. Let's hit the horizontal coil header pins. And we'll hit the vertical ones as well. You know, I'm gonna go do it through and do a complete total reflow right now. I'm gonna hit everything, and then we'll do some more. I'll cut back and we'll do some more testing here. So let me do a full reflow here. We'll come back and do a bit more testing here. Okay, full complete total reflow, and anything and everything that needed it is now done. I didn't see anything that was jumped out at me like that. You know, there's a crack. Oh, this is cracked. There's the problem, kind of thing. So let's just hit our normal suspects when we do our testing for having power issues and things like that. So let's go to our ohm setting and check R104. Should be 10K to 13K, and we're at 12.3. That's fine. Let's hit our voltage regulator, this guy right here. We should have, if I recall, 1.0 to this leg. There you go, 1.0, and this one should be our voltage drop. Yep, 0.5, 1.0 and 0.5, so that should be good. We can test our switch mode power supply chip. Pin 1, 2, 3 to 4 should be voltage drop. Uh-oh. Oh, there we go. Okay. And then pin 2 to 1 should be voltage drop. Yep. Pin 1, 2, 3, 4, 5, 6, 7 to 8 should be 1.5. There we go. And pin 6 to 5 should be 1.7. 1.9, close enough. I just realized I missed this. Okay. So we should have a good power supply section based off of that. We know Q703 is good. I hate this stupid heatsink they put on here because it causes it to bend and break, but that should be good. We know our HOT is good. Polycaps are good. Our normal things we check for vertical collapse is not going to cause an HOT to short, so I'm not worried about that. I checked all the traces and everything for the caps. I didn't see anything, any lifted pads, lifted traces. So I guess what we'll do is, let's do our light bulb test and test our power supply section so we can eliminate that as a cause or possibility. And then we can kind of see if we can figure anything else out. Because this looks like a brand new 7400. Yeah, crazy. So let's go ahead and do our light bulb test and just verify our power supply section, and then worry about the rest after that. So let's take L100 out. Alright, let's get our power connector, plug it in, Let's grab 1, 2, 3. This will go to our light bulb. This will go to our meter for our positive. We'll go to volts DC. And this will hold our negative onto the frame for ground. There we go. And okay, we just need a light bulb now, and I have that sitting here. Alright, so we're hoping to see around 170, 171-ish, 172-ish. And, yeah, okay. I think we are ready. 1, 2, 3. Holy cow, that's way high, way high. Let's test this, and it does work. Well, it goes down to 126. That's actually normal-ish. I'd like to see it around 124. But we have a good working power supply section, good B+ generation, so let's turn this off. And let's discharge it. You can see we're still... It'll eventually go down on its own, but I want to discharge it. Gone. So there you go. We have a working power supply section. Let's get these out of the way. Well, yeah, there's no R760 or R765 on the 7400 like we had on the U5000. Well, I say we just go ahead and try it. I don't want to blow up another HOT, but it's very possible it just simply was tightened too tight and punctured through on the insulator. Although I don't get that lucky. Let's go to ohms and we'll check R823 should be around 1.2. Close enough, 2.5. R303, 1.5. D302. D302 is good. D603. And we're hoping that it doesn't read the opposite way. And it does not, so our vertical IC is good. Our vertical, we should not have vertical collapse. Let's test. I think I've had it before where R402 was open, this guy here, and that was causing an HOT to go out. Nope, that's fine. This one, that's fine. I think this one's around 270. 220, I should say. But yeah, 4.1 is good. I'm pretty sure that's good. Yep, 4.2. Well, I say given that everything seems to be okay and there's nothing shorted on the circuit, because if we took the HOT out and checked the pads and it's still red shorted on the pads, something in the circuit is shorted. But since it's not, you know, it's quite possible that the HOT was shorted to the frame through the insulator. Let's verify that is not the case now. Let's go to ground and here. Okay, that's normal for the outside ones to be, but the middle one, yeah, it's not shorted to the frame. If we touch the actual ground here and we go to the frame, now wait a minute, I don't think that's supposed to be like that. I could be wrong. I'm wrong. I know for a fact this is the one I fixed before. So I guess that center screw does go. Yeah, I guess it's because it's touching this through the nut. You know, I didn't expect that to be that way, but as long as this part here isn't shorted, and it's not. Well, you know, you only live once. So let's put this back together, get it on a tube, and see if it takes the HOT out or if it works. But before we do, something I always forget to do is to put L100 back in. There we go. Alright, well I'm going to get this all back together on a tube and we'll see what happens. Alright, so we're all hooked up, ready to test. We got anode neck, yoke ground, video power, remote board. And I also have B plus hooked up just to see if it does take out the HOT, what it jumps up to when we turn it on, or what it goes to when it takes it out. But we may get lucky. I don't understand what could have taken it out because it didn't find anything wrong initially. Power supply section is good. Maybe it's, the reflow might have fixed it. I don't know. Let's find out. 1, 2, 3. Oh. Ah, interesting. Interesting. The B plus only went to like 90 volts. Interesting. So watch the meter here. We're hooked up to the correct test point. It hooks up right there on the 7400, the B plus test point. Watch the B plus when I turn this on. Yeah, it only goes to like 80 volts. I don't want to run it because we'll take the HOT out. Ah, so we've got some kind of B plus problem. Very interesting. Yeah, we don't have a horizontal, we may have a horizontal deflection circuit problem. And if, yeah, like I mentioned before, the B plus regulation was like at 180 volts initially. We may have to actually change out the HOT pot and see. Well, let's try it one more time. I want to see, if you look here, it should be 117. It only goes to 78 volts. Well, we may have to change out the B plus pot. Let's measure it and compare it to the one that's working and see if it reads something way wild off. So let's find out. One moment. Well, I tell you, if I had any hair left, I would have pulled it out because I've been shooting this for about 3 hours now, and I finally figured out what the problem was. I've narrowed it down. How about that, more specifically? So I wanted to change the B plus pot, changed it out, and after that, it did not fix the problem, but it actually got worse. It wasn't an issue of setting it wrong. I set it the same as the one that I took out. And after changing that out, it went from around 75 to 80 volts and cycling around. Now it just goes from 24 to 50 volts, the B plus setting. 24 to 50 volts, and just going tick, 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 tick. And it's not the HOT being shorted, it's the power supply section trying to power up and failing and trying to power up and failing. So I thought it was a shutdown pot problem. So I broke the glue loose and adjusted it to where it needs to be about 2.7 k ohm, and I'm getting 0.000 on the test point. So I'm like, okay, I thought the flyback was bad, just like the last video we had where we talked about having no test point voltage at 201 being bad flyback. But in this case, that was not the issue. The flyback actually provides voltage to test point 203 right here, and it should be 152 volts at this test point, but I only had 55 volts. And it comes right from the flyback through this cap, through a resistor and a diode, and right to the test point. And all those components checked good. So I had 2 strikes against the flyback. Only 55 volts here versus 152, and no voltage at the test point for 201. So I slaved in a known good flyback, and it made absolutely no difference. So yeah, what was left of the hair I did have all got pulled out at that point. So I thought, okay, that's very odd. So I thought, okay, let me try something I've tried before in the past, and I just started pushing down on the board. I pushed here, I pushed over there. When I pushed on these 2 heat sinks, pushed it down, the monitor came to life, and I had 117 B+. As soon as I let go of the chassis, it went back to tick, 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 tick. So we've got a cold solder joint or a broken pad that when I push down, the pad makes contact. So it's going to be it's going to be even more fun trying to track down this broken pad or bad solder joint, because I've already done a full reflow. But it's going to be interesting trying to track it down. So, but I've narrowed it down. So I got the new flyback out, and I put a known good one in. So I need to put this one back in because I know it's not the flyback now. But when I pushed this down and I got 117 B+ and the monitor came to life, about 3 seconds later, the C204 on the neck board. Let's see, this guy right here. I've got this cap right there. You can see the negative is towards the CRT socket and the positive is towards the edge. Well, on this one, someone put it in backwards. They had the negative down towards the edge and the positive up towards the neck, and as soon as I got B plus voltage and the monitor came to life and I read 117, no sooner did I read 117 and I'm like, oh no, it's a cold solder joint. Poof! This let all of its smoke out. And you can see that it's, yeah, it has exploded at the top. And it's just a hairline crack. I can't really even tell. But yeah, you can look at it and see that it's not good. So this got put in backwards. The only reason it didn't explode before is because the monitor never actually got active B plus to reach the neckboard. It only happened after I was able to break or get that solder joint connected by pushing on the chassis. So yeah, and you can actually see if I set it down here, it just kind of wobbles around. So we had a bad HOT and a C204 installed incorrectly are the only two issues so far. So we just had the C204 in backwards and the bad HOT, and I got to find the cold solder joint, and that should get this up and going. So just to show you what's going on here, if I just move this around here and set it in place, I'll turn this on, you'll hear it go tick, 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 and watch the meter here. Yeah, so you can hear it. Tick, 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 and the meter's going tick, 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 tick. Now, watch what happens when I push down on the chassis here. 1, 2, 3. It comes right to life. 118.2, 118.3, and we actually get, let's wait here a minute, we actually get an image. Come on, come on, let's go. It's tired. Oh, wait a minute. This stupid board quit working again. I can only do this, I can only have one hand here, but you can see it was working earlier. I had an image. There's no image now because this board, I've mentioned in the last few videos, is just it's temperamental. Sometimes it boots and sometimes it doesn't. I'll worry about that later. But you can see here I'm pushing down and I got my 180. If I let go, it stays running. But if I shut it off and just kind of set this back in place, let's see if it turns back on. Nope. Tick, 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 tick. So yeah, I'll push down again. And it comes right to life. Immediately it comes to life. So yeah, I got to figure out if I can. Oh, it just shut down again. So yep, I got a cold solder joint or a bad pad. I got to figure it out. That's where we're at. That's what's wrong with this. And it took about 3 hours of testing and troubleshooting and swapping neck boards and swapping flybacks and re-verifying connections and testing at resistors and testing these resistors and make sure caps are good. The whole 9 yards. It just was a headache. But yeah, so let's get this figured out and narrow it down, and I'll show what the actual joint was or the bad pad. I'll have to go through and do continuity tests, and it's going to be tough because, like I say, it only has continuity when you push on it. So I'll get it figured out, and then I'll cut away and come back. I'll show you what it was, hopefully, and we'll get this up and running. Well, I found the problem, and it was not, to my credit, it was not a bad solder joint or a bad pad, because I had already gone through and done all the reflow, and I thought, man, I hope I didn't miss something, because I was pretty darn sure I didn't miss anything. You know, my inspection and reflow process is fairly honed over the years, and it turns out it was Q703. Q703, as I've mentioned many, many times, is responsible for regulation of power in a specific way, where if you get a chassis that's, well, not necessarily dead, but was doing what it was doing, we had a bad Q703. So basically, when we tested this before, it tested fine. However, in the process of handling this and turning it over and installing it and doing inspection, it got bumped over like this, and the outer leg broke. And what happened was, it was just happened to be in a very particular position, where if I was to flex the board would bend slightly and it would reconnect, and I'd let go and it would unconnect, and vice versa. I can't really explain it, but the outer leg here was broken because I leaned it over and it was just separated in half, and it was just barely making contact. When you would push on the board, it would flex to a point to where it would flex and make it contact and then uncontact and contact and uncontact. So if I held the board down, it would do that. So it turned out to be Q703 was all the cause of my problem. So I got to get this out of here and get a new one installed. Let's just heat up the pads and pull these pins out. Ah, dang it. Okay, there's all 3 pins. All 3 pins on the bad Q703. So let's wick away this. All right. Let's grab a new one, and actually kind of foreshadowed this when I was doing the description, talking about Q703. I foreshadowed. I think I talked about how it can break if you bend it around and stuff, and I hate these heat sinks on there. I kind of foreshadowed this. So this is partly induced by me, because I think we tested it and it was fine before, but moving this around, it was just so brittle from being bent back and forth so many times before I got it, that it took that one last bend, it broke that outer leg. So let's get back through here. I've still got them on the outside here. I don't have any with the heat sink, and I don't think I'm going to be able to extract this one. Maybe I can, I don't know. I don't even want to put this stupid thing back on here, because it's just going to get bent over again. But that's the way they want it, and that's the way it's going to go. Assuming I can get this out of here. This stupid glue. Ah, success. So let's put this one on here. Get rid of our tape. Put this in here the very specific way that it's supposed to go. And solder it in place. Oh, you bastard. I got a bridge here. Okay, that looks good. All right. Well, so we'll add bad Q703 to our lineup here. And I went ahead and I thought maybe that I had already replaced the HOT. You saw me do it, and I put the 3688 that I had in here, and I thought that might have been bad. Even though it tested good, I thought that might have been bad in the cause of our problem. So I put one of the beefier FJL series in there, and it didn't fix it. So I'm just going to leave that one in there. It's not a big deal. It's compatible, and I prefer these anyways. So I'm just going to leave that one in there. But we had the shorted HOT, the bad Q703, and the backwards C204. And I actually have footage on my iPhone. I was taking video with the iPhone, and I caught on camera this thing exploding and letting all the smoke out. So I think I'll show that right now. That's not good. Oh. Yeah, so that was fun. It absolutely was in backwards. So, yep, the new one's in just the way it's supposed to be. So we had 3 separate problems here. Not too bad when you consider it, but it just shows how sometimes one little simple thing can bite you and send you down a rabbit hole, and eventually you come out the other end. But whether or not you come out the other end successful or not, that is the prize, if you will. So I think we're going to be good now. Let's get this back on a tube, and hopefully it fires up and is reliable, and I'll test it 3 or 4, 5, 6 times, and I'm betting that will be good now. So yeah, let's do it. Okay, time to test out our theory. Everything's hooked up, ready to go. I have not turned it on yet. We know our B plus was 117.8 or something from previous testing. So now we have our test point 201 hooked up to test our 0.1 for our shutdown. So hopefully it works. I didn't find anything else wrong. No other bad solder joints and whatnot. So it's got to be the Q703. I've already bent that stupid thing. Man, I hate those stupid heat sinks on there. But, okay. Yeah, let's see what happens. 1, 2, 3. Hopefully it comes right on. Yes! But our shutdown is 0. Oh, hey, there we go. 0.1. Outstanding. And we have an image. However, it is very pincushiony, very out of focus, and not even close to, oh man, look at that. Well, let's adjust focus here first. That's the top one, isn't it? Can I even reach the top one? There we go. Ah, beautiful. Let's zoom in a bit. That is super crisp. Man. I love these Polo tubes. The dot pitch of the Polo tube is just phenomenal compared to the Wells Gardner tubes, but unfortunately the Hanrex Polo chassis is a piece of junk. It looks great when it's working, but when it fails hard, and no one works on them. I haven't had a chance to get any across the bench, and if I do, I'll see if I can get them working, but they're just a massive headache compared to the Wells Gardner stuff. It's like opposite. Hanrex Polo tubes are great, but the chassis is junk. Wells Gardner chassis are good, but the tubes are junk. So, anyway, the K7400 was about the best looking Wells Gardner monitor that ever came out. Alright, so let's adjust our contrast down, brightness down. Right there is about okay. Well, no, it needs to go down a little bit for our flyback. We'll say right there. Brightness down to there. Contrast up. How about that? Yes. Okay. I'm not going to mess with width or height or vertical position or none of that stuff yet. Let's adjust our this tube. Oh, look at what's happening there. See, the red is flaking. The red's flaking, and that was happening on a different chassis. Oh, there it goes. That was happening on a chassis I was testing a few days ago too. Not for the channel, for my own personal stuff. Huh. I hope this tube isn't shorting out the red gun, because that would suck. Anyway. Seems to have stopped doing it. Anyway, so what I'm going to do, I'm going to adjust this little pincushion board, and I'm going to turn these pots, and you'll see how that's what this does. It takes the square image and makes it round. It curves the edges to fill the curved tube. But no one likes that. So you have to extend the outside way wider than you normally would if it was a square image. Stupid focus. So I'm going to adjust these pots, and it should square it up. In theory. Come on. Wow, that's the wrong way. That's why I just take these stupid boards off. Well, that's as square as I can make it. Yep, that's as square as I can make it. And that's not too bad. It's still kind of curved a bit, but not too bad. Okay, so let's do our width. H position, width, vertical position works, vertical size, hachi machi. I say we're golden. Yeah, the colors aren't exactly adjusted properly, but like I say, every time it's not staying on this tube, so we'll turn the red down slightly, green up a bit, blue up a bit. That's better. That looks really good. If it focus up here. There you go. That looks really good. Look at that. Glorious. Okay, another K7400 in the books. So we had, yep, let's see. We had the bad Q703, we had the shorted HOT, and we had the cap C204 on the neck board in backwards. So not too bad, but a little frustrating trying to get this figured out. And why is this stupid? Well, that shutdown pot is touchy. Okay, we saw it was 0.1, and I just checked it was 0.68, or 0.0068, and it jumps all around here. Yeah, close enough. It's right where it should be, so we'll leave it there. But okay, I'll let this run for a couple hours, and all of these chassis, with the exception of the Cortec, because I have no flyback for it, all 4 of these will be going back to the owner, and I'm sure he'll be happy. And stay tuned for more content. Got some more on the way. It never ends. So thanks for watching. Like, share, and subscribe. And we will see you next time.